Hello and welcome. In this tutorial, we will learn about loops and its use cases in Python, so let's get started. We have seen in the previous section how powerful is the use of Boolean conditions. We were able to direct the flow of our code to execute certain body of code or expressions based on single or multiple conditions in the if, else clause and elif clause statements. The use of conditions in Python does not stop here. We can use them in what is called as loops. Loops are one of the most powerful and helpful concepts in programming. The purpose of using them is to provide an instruction that repeats itself until a specified condition or conditions are met. If you have a task that requires repetitive executions, then loops are the way to go. As we will also see, conditional statements that we have already learned can be used inside of loops. So, in this tutorial, we will learn about the functionality of loops and its variants. Now suppose you have a list called fruits which consists of the following entries, and you would like to print each item in the list. Doing it the conventional way would require you to print each item using indices as follows. Executing it using this method would require you to write lines of codes equal to the number of items in the list. This is not practical and not efficient because if your list has large number of entries, you will need to write big chunk of code. Luckily, you can solve this problem using loops. As you notice, what we want to do is access each element in the list and print it, then go back to the list and print the second item, and so on. So you see that there is a repetitive process in which you have to sequentially access each item in the list and print it. Let us look at the syntax of the for loop and see how to implement the same problem. The syntax of the for loop consists of multiple keywords, so let's define and understand each one of them. The first element is the for keyword, which tells Python that a for loop is required to perform repeated execution over its body, which is the expression. The second element is the iterable. An iterable is an object capable of returning its sequence elements one by one. A Python list object is an example of an iterable object, since it has a sequence of elements which can be accessed by an index number one by one. There are more iterable objects in Python such as strings, tuples, and dictionaries. We will cover those types in this course as well. Next, the var keyword is just a normal variable that holds a certain value. Hence, the collection of keywords var in iterable means that the variable var is responsible for holding the element values found in the iterable one by one. Lastly, an expression is any executable code. Now, let us see how this works through an example. In this example, we are creating a variable called letters which consists of a string value ABC. Then, we have a for loops that loops over each letter in the letters variable and prints it. In this case, the variable letter in the for loop is the same as the var in the for loop syntax. Letters is a string iterable, and the expression of the for loop is a print of the variable letter. Now, let's see how this works. First, the variable letter in the for loop takes first element in the letters variable. Therefore, the value of the letter variable is the character A. Then, since the character A is not the last element in the letters sequence, the expression is executed and the character A is printed. Then, the variable letter updates its value to second element of the letters variable, so the value of the letter variable is equal to the character B. Since character B is not the last element in the letters sequence, the expression is executed and the character B is printed. After executing the expression, the variable letter updates its value to the next element in the sequence, so the value of the variable letter is the character C. Since the expression at character C loop has not been executed yet, The expression is executed and the print function prints the character C. Lastly, since there are no more elements to update the variable letter, the execution of the for loop stops. Now, let us see another example. Here we are writing a simple program to calculate the average of numbers stored in a list called nums. In order to calculate the average of nums, we first need to add all elements in it, then divide the total by the number of elements in the nums list. The addition is first done by creating a variable that will hold the total addition of the elements in nums list called add. The initial value of the add variable is 0. Then, we need to access the elements of the nums variable and sum it to the add variable. Therefore, accessing the elements one by one of a list requires a for loop to loop over each element and sum it to the add variable. In the for loop, the variable number holds the values of the nums variable one by one. The variable nums is the iterable since it is a list, and the expression of the for loop is the add variable whose value is always updated, with addition of the new element stored in the variable number. Lastly, the average is obtained by dividing the add variable by the length of the nums list to get the average, and store it in a variable called average or avg. Now, up until this point, we understood that the var variable takes the elements' values of the iterable one by one before the execution of the expression. There is one drawback when it comes to using this syntax with the for loop. You see, the iterable is a single object that could be a single string or a list. However, what if you want to iterate over multiple iterables such as multiple lists? Then we need to use a different technique. The second technique is done by using the index numbers of the lists to access their elements one by one. In this way, we will be iterating over a list of indices to access multiple iterables in the expression of the for loop. Creating a range of indices to iterate over is done using the range function. This is the syntax of the range function. Its input arguments are start, end, and step. The start is an optional integer which specifies the starting position, and its default value is 0. The end input argument is a required integer which specifies the ending position, and it is exclusive. The step input argument is an optional integer which specifies the incrementation, and its default value is 1. Now, let us check an example. In this code example, we have three variables x, y, and z. X has range of 10 and so produces the following integers up to 9 since 10 is exclusive. Next, variable y has a range from 2 to 10, so it produces a range of integers from 2 to 9 since 10 is exclusive. The last is variable z, which is the same as y but introduces a step of 2, so integer values 3, 5, and 7 are omitted. It is important to know that a range function does not produce a list values. In fact, printing, for example, variable x will just result in a statement of the range function. Also, the range function has a range type in Python. However, a range function's output can be transformed into a list type using the list function as such. Knowing the syntax of the range function, we need to use it with the for loop as a generator of indices. Now, we will use the index method of the for loop to perform one-dimensional dot product. The dot product will be done by multiplying the corresponding elements in each vector and then add them together. Vectors a and b will be represented as lists for now, although such vectors are used as arrays. We will study arrays in future courses. In this code example, we are creating two lists a and b, each of which has a list of integer values. Then, we are creating the indices variable which will be used in the for loop to iterate over the indices to access the lists a and b. To create a range of indices for lists a and b, The range function's input argument must be the length of either list A or list B since both have the same length. Therefore, the indices generated are 0, 1, and 2. Next, we are creating the add variable with initial value of 0. The add variable will hold the summed values of the element-wise multiplication between lists A and B. In the first iteration, the index value is 0, and the value of add variable will be the first element of list A times the first element of list B plus 0, which is the initial value assigned to add variable. In the second iteration, the index value is 1, and the value of add variable will be 5 times 3 plus 2, which is the value obtained in the first iteration. In the last iteration, the index value is 2, and the value of add variable will be 10 times 6 plus 17, which is the value obtained in the second iteration. Therefore, the total addition is 77. In some cases, you want to create a new list from an existing list, so basically, you want to transform the old list to a new list whose values are based on an expression or algorithm of your own. This technique is called list comprehension. So let's see how it works. Suppose we have a list called nums which contains integer values, and you would like to create a new list whose entries are the squared values of the original list's elements. First, we will create an empty list called nums sqr which will accept and hold the squared values of the nums list. Then, we loop over each element in the nums list and append the square value of each element to nums sqr list. If you look carefully in the output of the code, you find that each element in the nums sqr value is the squared value of the corresponding element in the nums list. In this case, we were able to create the nums sqr list from the nums list based on a transformation that is squaring each value. As you already know by now, list comprehension required that you first write a line of code to create an empty list, to accept the required rule of transformation from an old list to create a new one. Then, write a for loop whose expression has the required transformation code. To make things easier, you can write the list comprehension in a single line of code. To do so, you can arrange the for loop keywords in this way. Note that the expression in the original syntax is not fully written in this new list comprehension syntax. Only the transformation is written. We can apply the same on the previous example as such. Notice that the append function in this case is not written as it is already embedded in the syntax of the list comprehension technique, and only the transformation, which is the squared value of num, is written. We have seen that the for loop runs for a preset number of times until the sequence in the loop is fully iterated over. However, now we are going to look at a different kind of loop which is called while loop. The while loop iterates over an expression based on a conditional statement, so the while loop is repeated as long as the conditional statement is true. The syntax of the while loop consists of 3 parts. The while word specifies that a while loop type will be used for iteratively accessing the body of expression, and it's the place where the loop starts. The second part is the condition which returns true or false. Finally, there is the expression which contains any executable code. Let us see how the while loop works through a factorial calculation. Just so you remember, this is equation that calculates the factorial of certain number n. First, in this code example, we are defining 3 variables f, k, and n. The variable f holds the latest updated value of the factorial. K is an incrementation value that will be used to update the value of the factorial f. Next, variable n will hold an integer number for which you need to find the factorial for. Why do we need variables k and f, you may ask? Well, the incrementation value k represent this part of the equation. Variable f will hold the latest updated multiplication value of k by itself. Next, we have the definition of the while loop. The condition of it is k less than or equal to n. This is because incrementation value k cannot exceed value n as per the factorial equation. Also, the expression has two lines of code in which you first use the value of k to multiply current value of f, and the next line is to increment the value of k by 1 in order to calculate the next element in the factorial. Now, let's see how this works through a flowchart. The initial values of k and f are set to 1. In the first iteration, the while loop checks the condition 1 is less than or equal to 3. This true, so the expression of the while loop is executed and the values of k and f are updated as shown in the table. Next, the while loop checks the condition again 2 less than or equal to 3. This is true, so the expression of the while loop is executed, and the values of f and k are updated as shown in the table. Next, the while loop checks the condition again 3 less than or equal to 3. This is true, so the expression of the while loop is executed, and the values of f and k are updated as shown in the table. Next, the while loop checks the condition again for less than or equal to 3. This is false, so the expression of the while loop is not executed, and the while loop terminates. The break and continue statements in Python allow you to change the conventional flow of a loop. Normally, a loop will keep executing its body of expression until the conditional statement is false in the case of while loops, or the sequence is fully iterated over in the case of for loops. Now, we will see how break and continue statements allow you to disturb the code flow to your favor. Let us look into the break statement first. The break statement is used in any kind of loops, and it is used to terminate the execution of code inside the loop. When a loop terminates, it means that the code in the body of expression will not be executed, and code outside the loop will be executed. Usually, the break statement is executed based on a condition using an if statement inside the loop in order to determine when you want the loop to terminate the execution of the code inside the loop. As long as the break condition loop is false, the loop will normally continue to execute as we have previously seen. Next, let us look into the continue statement. The continue statement is different from the break statement as it does not completely terminate the loop. The continue statement is used to skip the rest of the code inside the loop that comes after the continue statement. Similar to the break statement, the continue statement is coupled with an if statement inside the loop to determine when to skip the rest of the code. Remember, any code coming before the continue statement is not affected even if the condition of the continue statement is true. It is only the code after the continue statement that is skipped. Let us see an example to better understand the difference between the break and continue statements. We have seen this loop example which print every fruit name listed the fruits list. This code will print all items, banana, orange, apple, fig and lemon. But what happens when we set a break or continue statement constraint, say at apple item in the list as shown in the code? As you can see, in the case of the break statement, the code only prints banana and orange since the loop must be terminated when the entry of the list is equal to apple, and therefore the remainder of the list will not be printed. However, in the case of the continue statement, the code prints banana, orange, fig and lemon. Notice that the apple entry in the list was skipped as a result of the condition in the if statement. Since the print function comes after the continue statement, printing the apple entry was skipped since the condition of the if statement was true.